Okay, so it's before the final tonight, and I can't sleep, so I'm thinking about the things you guys had to learn. And um, I went through the item analysis for the practice final. It's a good way for me to kind of just see what I should expect in the final exam results. And hopefully I don't see big discrepancies like someone doing really bad on the practice final and then doing really good on the final exam, or the other way. But the first way would cause more caution for me. Anyway, I found this is one of the ones that was missed. And not all your tests are the same because questions are pooled, and then questions are provided in random categories or randomized from the pools. Okay, anyway, so this question is, which of the following statistics are unbiased estimators of the population parameters? So remember that statistics that we learned in chapter 1 are quantitative characteristics that describe sample data, and parameters are quantitative characteristics that describe population data. It's kind of redundant. We say it a lot. We say population parameter, but really all we have to say is parameter because since a parameter describes the population data, it doesn't need to be stated that it's a population parameter. We don't go saying sample statistic over here. Anyways, that's kind of all beside the point. So, to answer the question, there was an animation that you had. I don't know if you remember this. I'd shown it to you actually in another questions answer, but sometimes you know how I get lengthy. You don't necessarily need to watch the whole video. So if you hadn't watched it, this was the lead up. This was from about section 6.4, the lead up into central limit theorem, which was section 6.5. And the central limit theorem was one of the biggest things to learn in one of the biggest topics to cover in our elementary statistics class that we have here. And this animation is actually just pretty much stolen from the or borrowed, whatever, they probably had permission, from the Rice University Java applet that you can look up. Just Google Rice University sampling distribution, and they'll have a whole lot more tools available there. But this one is so important. I think the author probably just got permission to go ahead and use it. Let me go ahead and show you how you get there. You go into the multimedia library. I mean, if you're not Googling Rice University sampling distribution, then you go for our tool, you go into the multimedia library, you just choose chapter 6, go ahead and hit it all, and then the Java applet is the one that has the sampling distribution that I'm showing you here. So what it would allow us to do is it would allow us to basically, through a simulation, learn the development of the central limit theorem by investigation, and learn about those parameters that were able to be predicted in an unbiased way. And I'm not going to go through all of it, but the answer, let me just go back to the question, but it was kind of cool because you could choose to use the mean and the median, and you can see how like the mean would be predicted or the mean would be estimated, but the median wouldn't. It would be off, depending on the original curve. Now, if the original curve was normally distributed, there wasn't an issue, but remember that you could do a custom curve to really push the point, or even just one of they're skewed right there. That's a good one. And if you did the mean and the median and you compared them, you would see how off they could be, especially for smaller sizes of n. So let's see if I can just do this really fast. Actually, I'm so tempted. So I do it, and here's the population data. The mean of it is 15.5, and the median is 12.2. Then I come down here to the sampling distribution of sample means, and I look at the mean of that set, and it's 15.5. But the median is 15.14. Well, that doesn't really apply as much as this. Here's the sampling distribution of sample medians, and the mean is 13.5, so off, and then the median is 12.28, so on. So if you do a sampling distribution of sample means, the mean matches, and if you did the sampling distribution of sample medians, the median was coming in. Anyway, and then it let you do variance and standard deviation, and you would have seen that standard deviation would have been off, and variance would have been good. And the reason why, when I answered this question, I actually went to the 10th edition of the book to show you an old PowerPoint page that had been taken out, and then I posted that PowerPoint page on Piazza and in the Dropbox in case you guys wanted to kind of look through it more later. I posted it as a PDF. Anyhow, so the answer to the question is, and it's a multiple answer question, so maybe that's why some people missed it, but a lot of people missed this problem, and it should have been an easy one. Choose the correct answer, select all that apply, any that are unbiased estimators of the parameters. Well, that is proportion, that is mean, and that is variance. So anyway, I guess I can submit this test. I only answered one question. But maybe I'll do a few more of these most missed questions. So that was number 20. And not that you're going to really have any time to look at these, but since I can't sleep anyway.